Okay, with lesson 1.4, here's our second day. We're going to tie up some loose ends. We weren't able to finish yesterday, but we're certainly going to do so now. The big difference in these problems is as you look down below, you're going to see x headed towards either a positive infinity or a negative infinity. And in general, you honestly could divide the top and the bottom by either the highest power seen in the numerator or the denominator, but more frequently we're going to choose what? The highest power in the denominator, right? And if you do that, more often than not, you're going to see that things clean up in a hurry. Some of you might have already wondered, well, wait a minute, if I'm going to divide the top and the bottom by x to the third, that's going to look a little surprising. You'll get x to the fourth over x to the third. Down here, it's kind of nice. You'll get x to the third over x to the third plus 1 over x to the third. Cleaning this up, notice how I also continue to write the limit. If you lose the limit, like I'm saying, that's not right. You no longer are talking about approaching something in that regard. So, look, your numerator, x to the fourth over x to the third, is simply an x. Down below, well, you'd get 1 plus 1 over x cubed. Now, as x gets very, very, very large, 1 over x to the third is going to approach what? 0. So down below, usually kids will correctly point out that, well, that's like 1 plus 0. It's pretty much approaching a 1 down below. But up above, this is a whole nother situation. You just have an x, and as x gets super big, you've got x up here. Guess where we're headed? To infinity. There are times, guys, when a limit as x goes to infinity will have an output of infinity. Okay, and we're seeing that right here. Well, looking at example 9, there are two ways you could approach this problem. Sometimes kids will wonder, should I multiply everything out? Should I FOIL down below and distribute? Should I just multiply my terms up above? You may certainly do that. You may certainly do that. I'd like to show you a different way, though. Sometimes kids will wonder if you could more or less look at these two terms separately, because, by the way, they are separated by the parentheses. Look, if I just gave you negative x over x plus 1, what would you want to divide the top and the bottom thereby? Just an x. By way of comparison, you come over here. What do you want to divide the top and the bottom of that second fraction by? X squared. And sometimes kids will say, you can do that? Of course you could, as long as your limit is going to exist. You're going to see it will. X over x, of course, is going to be going towards a 1. X squared over x squared is going to be going to a 1 also. So this is getting interesting. Just want to show you this amazing situation where you could get a 1 up on top here, technically a negative 1. And down below, you'd have your 1 plus 1 over x. Here you'd have a 1 all over 5 over x squared. X squared over x squared is just a 1. But help me out with this fraction here. As x goes to infinity, what's that whole quantity going to be approaching? Well, it's negative 1 all over 1 plus 0, I hope you'd agree. That's headed towards 0. That's going to go to negative 1. Then you'd say, well, what about over here? Well, 5 over infinity is going towards 0. So that's 1 over 0 plus 1. You'd say, well, that's a 1 itself. Negative 1 times 1 is negative 1. And we are done. That would be it. You'd get the same answer, by the way, if you multiplied that all out. Okay, we doing all right? Now for the surprise. You might not be too surprised to see that this last problem on the page looks noticeably different. It's the only one that has that pesky square root. And you can think, oh my word, how do I deal with this? This gets to be a little bit tricky. And we definitely have to be very careful here. Guys, if you're looking at just the numerator, really what's happening up there, I hope you'd all agree, is the x squared controls the inside of that radical. And I'll tell you what we could do to make things a little different. I could divide the top and the bottom by radical x squared. Now that might look very strange, but it's going to really help you out. Look what's going to happen inside my radical. Sometimes kids will say, well, isn't that really the same thing as, just joining one radical? Here, I'll separate it for the moment. I'll separate it just for a moment. But, of course, where you're headed, guys, is that for this numerator, you're honestly saying that a radical A all over radical B is the same thing as just the square root of A over B. So this top up here is the same thing as radical 25x squared plus 1 all over x squared. And then you can even do an I heart math. Look at that. So the top is getting better by the moment. In fact, the top is looking much better. It's the denominator that seems to be more problematic. Because the denominator didn't have a radical whatsoever. But dare I say, let me just put a little squiggle over here and just have some review. Remember a couple of days ago, we talked about the square root of x squared and the shock of what it's really equal to. The square root of x squared is really what? The absolute value of x. The square root of x squared is really the absolute value of x. Why do I bring that up? You look in this denominator over here, and having the radical x squared isn't nearly as helpful as what we have up on top. By the way, here's some more review. Help me out with the absolute value of x. The absolute value of x is either what? X or the opposite of x, depending on whether x is positive or x is negative. We can move that over, and forgive me for writing so small. We could rewrite that. But I guess what I'm really pointing out to you is right now, as you're looking at this radical, x is going towards positive infinity. Is x positive or negative? It's positive. Guys, if x is positive, that means, please hear this, that the absolute value of x, which is really what x squared is just going to be an x. We all agree with that? Sometimes kids will say, well, why are you pointing that out? Guys, because this denominator, you've got 3x, the square root of x squared is really just an x then. And over here you'd have 4 all over an x. Wow. So let's see if we could get this thing cleaned up. It might have a little bit of a surprise to it. Usually kids look at this and they'll say, well, wait a minute, your x squared up on the top is going to cancel out. These x's right here are going to cancel out. Yes. What's the square root of 25 plus 1 over x squared as x goes to infinity? It's really the square root of 25 plus 0. Right? Help me out down below. What's this going to become? 3 minus 0. Guess where we're headed? Square root of 25, you know, is really 5. This is 5 over 3. Now look, I'm putting in a part B. Because so very often kids will look at part B and they'll just say, now wait a minute, isn't this just exactly the same? And frighteningly, no, it isn't. Because it's a negative x value. You see, as x is going towards negative infinity, guys, that's going to open up a whole different situation. Yeah, you still start off the same. You still divide by the square root of x squared. And we just saw not too long ago that this is effectively saying that we've got the square root of 25x squared plus 1 all over x squared. Just making this a little bit shorter work, you'll have this. And then you'll say 3x all over the square root of x squared minus 4 all over the square root of x squared. And it's so tempting to say, oh, it's the same exact thing. No, it isn't. Look up here where I wrote review. The square root of x squared is the absolute value of x. But the absolute value of x, if x is negative, when x is negative, guys, you're actually going to see the absolute value turns into the opposite of x. What are we really getting at? We're getting at this. Yeah, you've got 25 plus 1 over x squared here, but this becomes 3x divided by negative x. This is negative 4 divided by negative x. Negative x's have been introduced. This changes everything. So working this out, yeah, you get your x's to cancel out, but your denominator becomes negative 3 plus 0, and your top becomes 25, radical 25, with a plus 0. You get negative 5/3 here. So just by changing the direction of going from, instead of positive infinity to negative infinity, things are changed quite a bit. Tell you what, I'd like for us to maybe take a look at one homework problem that we did not see, and that's number 33, which is, by the way, a review problem. Because do you know what? You did this back in the first chapter that we ever worked on together. When you were with rational functions, working on them, you would factor, you would work things out, you would get vertical asymptotes, you'd get horizontal asymptotes. Tell you what, when you were back here, what would you always wind up doing? You would first factor. Help me out. Factor the top. What do we get? X plus 2, x plus 1. Yeah, you got to multiply to 2, add to 3. 2 and a 1 do the trick. Careful, guys. What about down below? X plus 3, x minus 1. Let's talk vertical asymptotes. Vertical asymptotes occurred where the denominator could equal 0. What vertical asymptotes would we have? X would equal negative 3, x equals 1. Right? That's where you'd get vertical asymptotes. You might say horizontal asymptotes. Oh my gosh, how can we do that? Well, we learned a shortcut, but I'll tell you what you've been doing so far, what you've been doing all along these last couple days is actively finding horizontal asymptotes if they exist. As x goes to positive infinity or negative infinity, you'll be able to work this out. Let's divide the top and the bottom by x squared, and we'll see what we get. Of x squared over x squared, here's 3x over x squared, plus a 2 over x squared. Down here we'll have x squared over x squared, plus 2x all over x squared, minus 3 over x squared. Well, the x squared over x squared is a 1. This becomes 3 over x. What does your top become as x goes to infinity? It just goes to what? 1 plus 0 is 1. How about down below? This is really a 2 over x Well, you